Good day. Today I'm going to talk about lifespan, about how long you live and why. I mean, why didn't we live as long as Methuselah? Why did we die at the age of 80 or 70 or whatever? In fact, a lot of my friends are dying or have died. So this talk is about radiation, genes and lifespan. Something that I have studied for the last 30 years and have come to some conclusions about. The argument and evidence that I present here is much more elaborately presented in my book Wings of Death, 1995. And this book is still available, price £55. We've got some of these left. And the cost of that supports the scientific work that I'm doing with my colleagues. So the question is, why do we age? Why do we wear out and die? What determines lifespan? The current expected survival time of humans is about 80 years. The survival over the period of life was expressed as early as 1825 by Benjamin Gompertz, an Englishman. He found that age-specific mortality rates increased exponentially over a considerable proportion of life, and then he assumed this was reflected in an exponential decline in some system. So it's like something is pushing you and something is pushing back. Incidentally, that's a very similar model to the model of primitive tribes. In 1990, I came across the work of Henry Eyring, who, with his student Betty Stover, addressed life as if it were a chemical reaction. Eyring was well, he didn't win the Nobel Prize, but he should have done. He was a very, very famous and clever physical chemist who was involved in reaction rate theory. In fact, he developed an awful lot of reaction rate theory as it's held today. So he knows about reaction rates, so why something happens and why it doesn't happen, sort of fighting in different directions. And he applied this to life. He considered life as a chemical reaction and tried to work out the mathematics, statistical thermodynamics as to why this was so, or how it could be so. And then he applied it to a lot of death, a lot of lifespan work that was being done with radiation at the Atomic Energy Commission, looking at the radiation effects on beagle dogs. They killed thousands of beagle dogs in Albuquerque, New Mexico, by injecting them with plutonium and radium. And the results of that, he tried to fit, or he saw if he could fit them into his model. And what you see here in these graphs are the survival curves from 0 to 100%. So in other words, 100% survival and 0% survival, they're dead. And the mean survival is at 50%. You can see the line and the dotted line in the middle there. And so the basic background lifespan of the beagle dogs is this curve on the right. And then as you inject them with plutonium, or in this case radium 226, which is an alpha emitter, it pushes their lifespan back. And the graphs there, you can see each little step there is a beagle dog dies at the particular dose. So how does this happen? Why is this happening? Well, we know radiation, the effects of radiation are all on DNA. Chromosomal DNA can be seen as an operational memory for cell identity. So in other words, a cell, in order to tell itself what to do, goes to the library of the DNA on its chromosomes, and it picks off that section of the DNA which tells it what sort of cell it is and how it should behave. And the two conjugate strands of the double helix are there because if something breaks on one strand, it can be copied, and this is copied during a repair cycle in the cell, from the other strand. So A is always opposite B and C is always opposite D, if you like to see. Like, so if something takes away C, then and D is still there, you put C back. You see. Of course, if you smash both of the strands at once, then the repair mechanism doesn't know what to put back, so it puts back a dummy. It puts back adenine. So exposure to oxidative processes throughout life result in damage to the DNA. And because cells replicate throughout life, not all of them but most of them, when they replicate they take the parent DNA and they check it all out, and then they send it down to the daughter DNA. So then the daughter DNA after a certain length of time does the same thing, and so on. And so you get a replication of cells in the order of a binomial sequence, which is 2 to 4 to 8 to 16 to 32 to 64 and so on. And as you can see, the number of cells carrying the mutation increase exponentially, just as survival does, okay, which is the Gompertz thing. So this can be expressed as a scientific equation, which I show you here. S equals 1 minus e to the minus a minus bt, all to the minus 1, so it's 1 over the reciprocal of that. Where b is the measure of the difference between damage and recovery, that's the weights. You can see that as weights on either side of a pivot. So you've got you've got the life force pushing this down, so the death force pushing this down in the picture here, so you die earlier, and the life force pushing it up, so that you die later, you live a long time. So that I called that in Wings of Death, I called that the seesaw of death, because in England this thing is called a seesaw. So if we consider factors affecting the survival S in that equation, basically is A and BT. When A equals BT, you've got a 50% chance of dying. So the death force, as I've just explained, is DNA mutagen concentration, radioactivity and chemical mutagens, but mostly radiation, I have to say. Then, of course, if the repair efficiency is not good, that's also a death force. So if you've inherited a poor efficiency in DNA repair at the point where the cell divides, is bad. Then factors affecting the immune system, physical and psychological stress. Well, the immune system is important, but I won't talk too much about it here. I'm going to do another talk about cancer, in which I'll go to the issue of the immune system picking up prototumors and causing them to kill themselves through apoptosis. Then, of course, you have inherited mutations. So the A in that side, or the B in that side, is affected by what mutations you get from your parents. I mean, if your parents were born at the time of nuclear fallout, for example, as I will show, you're going to have a lot of mutations that you get from the fact that your parents had the mutations, and then they gave them on to you, and you'll give them on to your children if you've got any. Then, of course, there's inherited cell responses to DNA damage. This is what I was talking about, the immune system, the apoptosis response, and, of course, time. So the longer you live, the more of these things go wrong, and the more copies of copies of copies, eventually the whole thing is smudged out, and the cells don't know what to do. At that point you get cancer, or the cells just die, and then you get old, and you creak about the place, not being able to be very strong, you can't lift things, and so on. But then all sorts of life force things. So the diet, you've got diet, which includes DNA repair enhancement substances like vitamins, vitamin C, vitamin D, selenium, that sort of thing. Then you've got good DNA repair efficiency if you're lucky enough to be born with it, and factors enhancing the immune system, such as security and peace and happiness and psychological ease, all that Green Party stuff. And of course no inherited harmful DNA mutations. Now, if all this is true, it must be true for all mammals, and in fact it is. So what we see here is a result of studies that were carried out by the Atomic Energy Commission researchers and people funded by them in the 1950s, where they were interested in the effects of radiation on cancer and on lifespan and so on. And what this shows is fairly obvious, so I don't need to explain it all. You can look at it. I'm putting this up as a PDF on academia and on ResearchGate, so you can download it and look at it. On the left-hand side, we see a set of graphs there that show the effect on lifespan of various different mammals of different amounts of radiation, and you can see that the mouse doesn't live very long and the humans live a long time and so on. But the most important takeaway from this is that lifespan is proportional to radiation resistance. If you take the amount of radiation for any mammal that's necessary to kill half of them, half of a population, called the LD50, that's the lethal dose for 50%, okay? You find that that's proportional pretty much to lifespan. Now that is such an extraordinary thing. That means that it's radiation that causes us to die. And if there was no radiation, we would probably live forever, or certainly for very much longer than we do. And of course, with all the radiation in the environment at the moment, obviously lifespan is going to drop. And without all of the technical developments in medicine, probably it would have already dropped, and I think it is beginning to drop anyway. So there's the evidence, or some evidence. And some more evidence is from you saw the beagle dog curves where they're displaced to the left, so in other words they die earlier when they get the plutonium. Well, here's a similar thing in human beings. So these are patients that were injected with thorotrast, which is thorium oxide. Thorium's got a very high atomic number, and so it blocks X-rays. So as a contrast medium, it was used in the 1950s in order to image things. So a lot of Japanese studies and a lot of studies were done in England and in America and so on of thorotrast. But this particular study by Mori actually gave a graph with all the data points on it, and I carefully measured the data points with a ruler and turned them into this graph here, which you can see here that in the women in all Japan 1970 versus the female percent deaths in those who were given thorotrast for X-rays, that we've got pretty much a 20-year loss of life here from the thorotrast people relative to all Japan. So to summarize, just as the Romans, and we now know the Romans all went off their heads and the Roman Empire collapsed because of the clever technologists in Rome deciding to make lead water pipes. Everybody had loads of lead in their bodies, and of course that makes you crazy and it makes you stupid. And so the empire collapsed, and what we've got here is we've got the stupid physicists who work for the military and the nuclear industry who see this issue quite apart from biology. They don't consider biology, they consider that lower class. So they see the human being as a bag of water into which you introduce energy, and on the basis of that, their risk model enables them to say that the tiny amounts of energy from the alpha particles and so forth that come from radium and so forth, and from plutonium, or from the compounds or from the elements that bind to DNA, like strontium and uranium, that they can ignore those. But so by doing this, they've taken this to the next level, and they're destroying the human race. They're destroying all life on Earth anyway, and that's going to get worse because they want to make more nuclear power stations and produce more nuclear waste. Although the evidence in the last year published in the literature shows that their risk model that enables them to do this is just totally dishonest, false, and arbitrary. So, in 2024, a Chinese researcher and his colleagues, a chap called Zhu, published a report that showed that cancer was increasing in the northern hemisphere in young people under 50. Well, young people under 50 are people who are the children, by and large, of the mothers and fathers who were exposed at the peak of the nuclear testing, atmospheric testing, mostly in the northern hemisphere. This stuff wasn't mostly in the southern hemisphere, which is another clue to what's going on here. Now, I wrote a letter to the BMJ in which I pointed out that I had already done an interesting study for my own interest. This was way back, where I looked at a ratio between cancer mortality in the United States, in states of the United States where the fallout was very low. This is California, this is the west coast, where it's dry, where the cowboys ride about in deserts, so there's no fallout there because it doesn't rain, not very much. And I took a ratio of the cancer there to the cancer in the southeast. That's Tennessee, Alabama, Mississippi, Kentucky, Arkansas. And you can compare the two, because all this data is available from the website of the CDC, the Center for Disease Control. Okay, you can get all this stuff. And so I divided the mortality rates in the high rainfall areas, the high strontium-90 areas, by the low strontium-90 areas, and I got this value R, which is this ratio, R for ratio. And it shows the excess risk of dying from cancer in the high rainfall areas relative to the low rainfall areas by cohort year of birth. So what we're doing now is we're plotting by year of birth the cancer risk relating to fallout, basically, or to rainfall. But we know it's fallout because they measured strontium-90 in all of these places, and so we got those numbers as well, and I put them in my paper. And then the BMJ published this letter, and later on I published the paper itself. So if you want to find it, you just look on the Google, you put in Busby cancer fallout, and you'll go there immediately. And you should do this because it's very interesting, and also not more than interesting, it's something that should be on the front pages of every newspaper, because everybody's dying of cancer. There's an enormous cancer epidemic. They all say, oh, you know, in the next 10 years cancer will be 1 in 2. In the 90s it was 1 in 5. And after 1952, around about that time, before all the fallout really came along, it was about 1 in 9. So cancer is the new epidemic. That's what you die of. You die of cancer. And everybody, all your uncles and aunts and mothers and fathers and dogs and cats and parrots are all dying of cancer. The question is why? Well, the answer, we know the answer. The answer is given by this study that I just did. And here it is. So if you look on the left-hand side here, what you see is what happened to the babies at the time of the fallout. On the left-hand side there's a red peak and a blue peak. The red peak is the strontium-90 in milk, and the blue peak is the strontium-90 in children's bones, measured. So this is real stuff. This is data. This is fact, if you like to call it that. And on the other line there you see a big bump there, which is early infant mortality in the United States. Early infant mortality is in the first 4 weeks. And this is pretty much always congenital malformation, because the baby can survive in the mother's womb, because the mother picks up all of the problems. The mother's kidneys clean the blood, and the mother's heart beats and pumps the blood into the oxygen and so forth. But once the baby comes out, if it's got some problem, it's got a heart defect or some kidney defect or some other congenital malformation from the radiation, then it can't survive and it dies, and there they are, they're all dying. And on the right hand side is my ratio. So what this basically is turned into is an excess relative risk of cancer mortality. So in other words, if you see there at the 50 line there, you can see the peak there is in 1955 to 1964, and that's when the fallout came down. You can see that on the other side there at the strontium-90 peaks there. That's when all the big testing was done by the United States and by Russia mainly, but also some stuff from the UK that was done in Christmas Island. And I know about all of this stuff because I represented the nuclear test veterans from Christmas Island in the High Court in London in 2016. So what we see here is the effect. That should be on the front page of every newspaper, because that is the cause. That shows the cause of the cancer epidemic, which I predicted in 1995 in this book. I predicted it, and in fact I wrote a letter to the British Medical Journal then, which was published in 1994, just before the book came out, in which I argued that there was going to be a cancer epidemic. Well, now there is a cancer epidemic, and we now know why, and the reason is the reason that I gave in Wings of Death. Okay. Well, in the next lecture I'm going to talk about cancer and the reason why the rates have been increasing for the last 20 years, more of the same in what I've just said here. But I will also talk about how it works, about how it's a genetic disease and how it can be controlled by controlling the cell communication between the cells surrounding the prototumor. Because you get cancers all the time, you know. Lots of work has been done on autopsies for people who didn't die of cancer, and they found little tumours all over the place, but those tumours go away because they get picked up by the immune system and killed. There's some new ideas online about cancer not being a genetic disease but being a metabolic disease. Well, I need to rebut that because it's a cop-out for the nuclear industry and for all the other people contaminating the planet. Cancer is not. It is not a metabolic disease. But it might be controllable through metabolic approaches, which I will discuss in another video. Anyway, so thank you very much for listening to this, and watch this space. I put up a slide about green audit and what it does and so forth. And we're working on a new version of the ECRR, the European Committee on Radiation Risk report, which we could do with some help with. So thank you for listening, and good day.